All right, so we are going to go ahead and enter our pyramid section. So we are going to go over square, rectangle, and triangular pyramids. One thing to keep in mind is the pyramids are based off of what the base is going to be. So meaning the bottom of our pyramid, whatever shape that is going to be the type of pyramid we have. So we have a square, we have the triangle, of course, and rectangle. And we're going to start off with square. So looking at my square pyramid, I am going to sketch you a quick pyramid. I have my square as the base. And then this line right here, this is going to represent my height of the pyramid, okay? So this is actually the middle of the pyramid, and where they connect right here at the top, that is the apex of my pyramid, okay? So when I'm labeling my base, those are going to be the sides. Remember, squares, they're all the same measurements with squares. So I'm just going to put side, and then I have my height. So that middle line right here is going to represent the height of the pyramid. Okay, now what a square pyramid is, it's a solid figure. Okay, whose base is a square and the sides are triangular faces that meet at the apex, which we talked about is the point, the very top of our pyramid. Okay, now when we're talking about the faces from the past, we've gone over faces. Remember, that is talking about our flat surfaces of our three-dimensional shape. So going to my camera really quick, I have my three-dimensional shape. As you can see, I will show you different angles. Okay, so this is what my three-dimensional shape looks like. And as I look at this, remember, we're looking at those flat surfaces. So here's one flat surface right here. This is flat. I have 1, I have 2, 3, and then 4. And we cannot forget about the bottom part, which is 5. So I have 5 faces, okay? And what those 5 faces are going to represent, they represent the square base, which we talked is at the bottom. And they also represent our 4 congruent triangular faces because they all have the same measurements. Okay, now when we're talking about edges, edges are going to be where our 2 faces connect. So you're going to see that along the pyramid. You can kind of think about them as like the lines. So going back to my camera, this is an edge right here. So this is a line. So 1, 2, 3, 4. And when I go to the bottom, I have 5, 6, 7, and 8. Okay, so I have 8 edges. And then our vertices are going to be our points. Okay, so looking at my apex right here, that's a vertice. Looking at the bottom, I have 2, 3, 4, and 5 on the other side right here. Now, I've talked about this on the other videos. You want to be careful that you are not counting the vertices more than once, because it can be a little confusing sometimes if you're flipping around this shape. It is possible to count it more than once, okay? So you want to make sure you are counting the vertices only once and not twice. All right, now when we are looking at a horizontal and vertical slice, we are looking at, if I have this shape right here and I cut it horizontally or vertical, what shape am I going to have on the inside? So I am once going to show you my shape right here. Kind of looks like a pyramid, a square pyramid. I tried my best, okay? Now, we're going to first start off with a horizontal, because on the example, on our notes, the first cut is horizontal. So looking at my horizontal, okay, I'm grabbing my slicer, and if I slice this horizontally, what shape am I going to now have on the inside? And if you look on the inside, it represents the same thing as our base, okay? So that means when I am working with a horizontal slice or a cut, I'm going to have a square for that slice, okay? Now looking at a vertical slice, once again, I'm going to try and put this together as much as I can. Okay, kind of reminds me of Patrick's star. I'm going to cut it vertically this time. Okay, and now looking on the inside, what shape do I have now? Okay, and if you look at the inside, this time we have triangles, which, once again, if you look at the sides of my pyramid, the sides are triangles, okay? So you can also look at the base and the sides for the horizontal and vertical slices. So for the vertical, I have a triangle, okay? So when we are talking about nets, that's just me flattening out my three-dimensional object so it can look like just straight on the table. You can represent it. So what you can do is you can think about it as me cutting along the edges so I can lay this three-dimensional shape just flat on the table, okay? Now, my representation, looking at my pyramid, here is my pyramid, three-dimensional, and if I cut along the edges, it starts unfolding, unfolding, and unfolding. So there you can see that I have my 2D net of my square pyramid. So it becomes 3D to 2D. It is now flat on my desk, okay? Now, if it's flat on my desk, can I really represent any type of height on this? Is a question you should ask yourself, okay? And that is going to be no, okay? With pyramids, obviously, if we're looking for the height of something, we're looking at how tall something is. And if it's flat on the table, you can't get the height of that, okay? So you want to make sure when I'm labeling my net, you cannot represent your height. The only thing that you can really represent are your sides, okay? So I have a side, and so on. And I'm going to put a side comment over here. Height cannot be seen on a net. Okay, so height cannot be seen on a net. And these are the attributes of my square pyramid. Okay, now moving on into volume. So like I've mentioned before, the pyramid really depends on what type of base we have, okay? So this is also going to be the same thing on our formula, okay? We have our formula for any type of pyramid is 1/3 times the base, which is the area of the base, times the height, okay? Now, our B, which is the area of the base, can change according to what pyramid we're working with, okay? In order for me to find that area of a base for our square, that is just 1/3 times S squared times height, okay? The B, and you can put a side note on that, is just base is the area of the base. So like I've said before, when you are looking for B, you're just looking for the area of the base. So that will change as your pyramid changes as well. Okay, now starting off with volume and using my equation that we got here, okay, I have volume is equal to 1/3 times s squared, which s squared is just the sides of my base, times the height of the pyramid. Okay, so I'm going to go ahead and bring down 1/3 because there's nothing for me to really plug in that 1/3. And then I'm going to move on to the sides. If I look at my square, which is the base of this triangle, or this pyramid, sorry, I have that my sides are 18. So I'm going to plug in 18 squared times the height of my pyramid, which is that middle line straight down the middle, which is represented by 16 feet. Okay, now I like to break this down, so I'm going to simplify my exponent first. So 18 squared is equal to 324. Okay, and then I brought these two values down because the first thing I did was simplify my exponents, and now I'm going to go ahead and multiply. Okay, so 324 times 16, that is equal to 5,184. And when I multiply it to 1/3 or divide it by 3, my final answer on that is going to be 1728. So 1,728. Okay, now this isn't my final answer because you still have to put a label to it. So my final answer is 1,728 cubic feet. Okay, and once again, we're doing the same thing with B. So first thing, your equation. My second step is going to be substitution. 1/3 is going to be brought down because there's nothing for me to substitute there. If I look at my base, so the bottom of my pyramid, that is once again a square, and the side measurements to that is 30, so I'm going to have 30 squared times the height of my pyramid, which is located in the middle right here, and that is represented by 21. So I'm going to multiply by 21. Okay. I'm going to go ahead and only simplify my exponent first. So I have 900 from 30 squared, and I'm bringing the rest of my values down that I haven't done anything with. Okay. And now I'm going to go ahead and multiply everything through. So 900 times 21 is equal to 18,900. And when I multiply it to that 1/3 or divide it by 3, my final answer is 6,300. Okay, and to finish this off, just put a label to it. So I have 6,300 centimeters cubed, or cubic centimeters. Okay. All right, now it says the Pyramid Arena in Memphis, Tennessee is a square pyramid that is 321 feet tall. And the base has 600-foot sides. Okay, so that means that every side of this square of the base is going to be 600 feet. Okay, now it says find the volume of the pyramid, round to the nearest tenths if needed, and show the formula substitution and all work. Okay, so my first step is going to be writing down my equation, which is V is equal to 1/3 times S squared times the height. Okay. My next step is going to be to start substituting my values. So I have 1/3. I'm plugging in 600 squared for my sides because it says the base has 600-foot sides. And then my height of the pyramid is given to me at the very first sentence, which is 321. Okay. Now, starting to simplify, I have 600 squared, which is going to equal that 360,000. And I'm going to bring the rest of the values that I have not multiplied. Okay, and then when I multiply 360,000 times 321 times 1/3, or dividing it by 3, my final answer is going to be 38,520,000 cubic feet. Okay, it's big numbers. All right, and moving on to our very last example of our square pyramid. So we want to be careful with these type of problems, because if I read the first sentence, it says an ancient stone pyramid has a volume of 1,234.2 cubic meters. So they are giving me the volume instead of me solving for the volume, which we have been doing in the last couple of examples. So I'm just going to start off by writing my equation. Okay, and then finishing off reading it. So now it says the edges of the square base are 16.5 meters. Find the height of the stone pyramid and round to the nearest tenth if needed. Show the formula and substitution and all work. Label your answer. Now, here's the thing. It's asking me to find the height, and the height is represented by h. Okay, so that means that there's nothing for us to plug in into h. We have to solve for h. So I'm going to start off by plugging in my information, which V is volume. So I have 1,234.2 equals 1/3. And then it told us that our sides are 16.5 squared times h, okay? So I finished substituting all of my values. I don't have height, so I'm just keeping h as a variable. And now what I'm going to do is I'm going to start simplifying the right side of my equal sign, because there's nothing for me to simplify anything on the left side of that equal sign. It's just 1,234.2. So I'm going to go ahead and bring that down. And then I'm going to simplify. So 16.5 squared times 1/3 is equal to 90.75 h. Now, another thing to keep in mind is if I'm looking at this equation, in general, I do not have any addition or subtraction signs in here, so there should be no need for you to add or subtract, okay? It is 90.75, and that is technically a coefficient. So going back to our equations first semester, if I have a coefficient and it's stuck to a variable, I'm actually dividing by the coefficient to get the variable by itself. Okay, so I'm dividing 90.75 to get h by itself. Now 90.75 divided by 90.75 just gives me 1, which is the same thing as just a variable. And then when I have 1,234.2 divided by that 90.75, my final answer is 13.6 meters. Okay, now notice how I did not put cubic meters. Okay, I don't have a 3 as an exponent because we are talking about the height. We're not really talking about volume, and the only time we use cubed in the label is when we are looking for volume. Okay, so this is just the height. So this is my final answer. I don't need a cubed. All right. Now, if you need to go back and look at square pyramid, go ahead and do that now. Or if you're ready to move on to the next one, we're going to go ahead and move on to the next one. Now, with our rectangular pyramids, same concept as a square, okay? The only difference is instead of us just squaring our sides, our rectangles consist of different measurements as our base, okay? So if we go back to our rectangular prism, we have length times width times height. We're going to have the same thing, except we're just multiplying it by that 1/3, because if you look at our pyramid, we're shaving the sides to make it into more of a triangle and a pyramid, okay? So we don't have that full volume, and that is why we're multiplying it by that 1/3, okay? Now looking at the rectangular pyramid, once again, instead of having a square at the bottom, I'm going to have a rectangle. This is my length, this is my width, and then when we are talking about height, we're talking about the height of the actual pyramid, okay, which is right there. Now, what a rectangular pyramid is, it's a solid figure whose base is a rectangle and the sides are triangular faces. And once again, when we're talking about that triangular faces, they meet, or that meet, at the apex, which is the top of the pyramid. Okay, so a solid figure whose base is a rectangle and the sides are triangular faces that meet at the apex or the top. All right, now, once again, we are looking at the number of faces. The good thing about our characteristics with the rectangle and the square pyramid is that they hold the same characteristics, meaning the number of faces, number of edges, and number of vertices. The only difference will be your horizontal slice and then what the number of faces actually mean. So I'm going to go ahead and show you my square pyramid once again to show you the number of faces, number of edges, because I do not have a rectangular pyramid. But just keep in mind, instead of me having a square at the bottom, I'm going to have a rectangle. Okay, so going to my camera really quick. Here is that square pyramid again, but once again, they have the same characteristics as a rectangular pyramid. So I'm still going to have the same number of faces, which are the flat surfaces of my three-dimensional shape. So here's 1. There's 2 on the side, 3 on the other side, and then 4 on the back side. And the very last face that I have is 5, which it's at the bottom. Okay, so I have 5 faces. And this time, what the faces are going to be represented by are a rectangular base, or a rectangle base. Okay. And since our rectangles are different measurements on, meaning like the top, or not the top, the front and the back and the left and the right, they are different measurements. So that means that our triangles are also going to be different measurements, but they're in sets, okay? Because the left and the right are going to be the same, and the front and the back are going to be the same. So it is 2 sets of congruent triangles or bases. Okay, and by that I mean like the front and the back once again, or the left and the right. Okay, going back to the pyramid. Okay, we're looking at the number of edges and the vertices. So remember, the edges are where the 2 faces connect. So it kind of makes this like fold or the line. So I have 1 here. I have 2 right here. I have 3 and then 4 in the back. I can show you around. There's 4. And then I also got to count the bottom. So looking at the bottom, I have 1, 2, 3, and 4 at the bottom. Okay, so I have 4 at the bottom and 4 at the top of the pyramid, so that makes 8 edges. And the number of vertices, okay, when I'm looking at the number of vertices, it's the points where a bunch of our faces. So if I look at the apex, that's where all 4 of my triangular faces meet. That's 1. Then I have 2 down here, 3, 4, and then 5 in the back right there. Okay, so the points. So I have 5 vertices. Okay, and then we're going to look at those horizontal slices. So instead of our horizontal slice being a square this time, it's just going to be a rectangle, because that is the base that we have for our pyramid. And then the vertical sides are going to be our side. So what kind of shape do we have on the sides? Which is a triangle. Okay, now if I were to show you an actual example of that, if you want to go back to the first one for our square pyramid, you can also do that, or I can try and make one really fast about our square, or not square, sorry, our rectangular prism, or pyramid. Well, it's hard to multitask. Okay, so going to my camera, this is the best I can do for a rectangle pyramid, okay, if I do a horizontal cut, it's going to give me a rectangle, as you can see. All right, and then if I do a vertical cut, straight down the middle, those are going to be triangles, okay? Now, obviously, it'll look a little bit better if I had actual shapes of those, but that is the best I can do, all right? Now, with the 2D net, once again, it's going to be the same thing, except instead of me having a base as a square, it's going to be a rectangle. So I'm going to draw my rectangle first, okay? And then I'm going to draw my sides of my triangle. Okay, because remember the 2D net is just me cutting along some of the edges and making a 3-dimensional shape into a 2-dimensional shape. And I'm going to go ahead and label my sides as well. So remember, I have a length and then I have a width. Now, I have a length and a width. When we drew a sketch of my rectangular pyramid up here, I also had a height. But when I flatten something out, I no longer have a height. So I have that height, once again, cannot be seen. Okay, so the height cannot be seen. Now, another thing I want you to kind of take in mind here is looking at the number of faces. Remember how I said you have 2 sets of congruent bases, which mean the front and back and left and right. If you look at the left and right triangles I have on my net, they're congruent to each other. And then I also have my front and back triangles. Those are congruent to each other. So they're different measurements because of the rectangle that we are dealing with now, okay? All right, now moving to volume. So our generic overall volume that we have for pyramids is 1/3 times the base, which is the area of the base that we have, times the height. And if we're getting a little bit more into specifics, we have 1/3 times the length and the width, which that's how I find the area of a rectangle, times the height of my pyramid. Okay, so going down to example 1, remember, always write down your equation or formula, which is 1/3 times length times width times height. Okay, then I'm going to bring down my 1/3 before I start substituting because I don't have anything to substitute there. Okay, and I'm going to look at the length of the base of my pyramid, which is 32 right here. So I'm going to plug in 32. Okay, then I'm going to look at the width, which is 17.5. And then the height, which is from the middle of that rectangle all the way to the apex, which is 24. Okay, notice how we did not touch that 30 feet at all. That 30 feet represents the slant height of this pyramid. And we have not talked about slant height at all, and it does not require you or say anything about a slant height in our formula. So you do not touch that 30. Okay, now I'm going to go ahead and start simplifying. I'm going to multiply 32 times 17.5 times 24 first. So I'm going to bring down that 1/3. And when I multiply 32 times 17.5 times 24, that is equal to 13,440. Okay, and now all I have to do is multiply it by 1/3 or by the decimal form, which you probably don't want to do that because it's going to give you a repeating decimal. So just multiply it or divide it by 3. And when you multiply 1/3 times 13,440, your answer is going to be 4,480. Okay, now this is not my final answer, because remember, you have to have a label to it, okay? So my final answer is going to be 4,480 cubic feet. Okay? All right, moving on to example B. So writing down my formula first, always your first step. So I have V is equal to 1/3 times length times width times height. Okay, my next step is going to start substituting. I don't have anything to substitute that 1/3, so I'm going to bring that down. Now my length of this pyramid is 7. My width is 8. And my height is right here, which is 12. Okay, now here's another thing to keep in mind. Remember, it doesn't really matter what order I have these in because we're just multiplying these. So you're gonna get the correct answer if you multiply correctly, but it doesn't matter which order because you're gonna get the same answer. Okay, now 7 times 8 times 12 is going to equal 672. And if I bring down 1/3, my next step is going to multiply 1/3 times that 672, or divide 672 divided by 3, which is equal to 224. Okay, and to finish off your final answer, it is 224 cubic centimeters. Perfect. Okay, moving on to our story problems. We have, find the volume of a pyramid that has a height of 9 centimeters and a rectangle base with a length of 7 centimeters and a width of 3 centimeters. Round to the nearest tenth, show your formula, substitution, and all work, label your answer. So my first step, once again, 1/3 times length times width times height. Okay, bring down my 1/3. And I'm going to go ahead and start substituting. So I have that my length right here is 7 centimeters. My width is 3 centimeters. And my height of the pyramid is 9 centimeters. Okay. Now all I have to do is simplify by multiplying all the way through. So 1/3 times 9 times 7 times 3, or you can multiply 7 times 3 times 9 first. Depending on what you want to do, your final answer is going to be 63 cubic centimeters. Okay. All right. And remember, if you don't know how to plug these into your calculator, make sure you let us know so we can help you with that as well. Okay. Now, moving on to example D. This is another one of those examples where they actually give us our volume first. Okay. So we have to be very careful with that. Now, a rectangular pyramid has a volume of 525 cubic feet. It has a base of 25 feet by 18 feet. Find the height of the pyramid, show the formula, substitution, and all work, label your answer, okay? So they give us the base, which is that length times width, and they also give us our volume. So the only thing we do not have any value to plug in for is h, which it's telling us, hey, you have to find the height of the pyramid. So I'm going to start off by writing my equation, which is 1/3 times length times width times height. Okay. And then I'm going to move on by substituting, which is my second step. Now it tells me that it has a base of 25 feet by 18 feet. Okay, so that means that it doesn't matter which one length and width is. I just know that both of those are going to be the measurements for length and width. So I have 25 and 18. And I do not have anything for my height because they're asking us to find the height. Now I do have something for volume, which is V, and that is at 525 cubic feet because that is our volume. Okay. Now, same process. You want to keep in mind that there is no addition or subtraction sign to begin with, so there should be no adding or subtracting or moving something to the other side by adding or subtracting. This is strictly multiplication here, so we're going to end up dividing or multiplying. Now, I'm going to simplify the right side first, so I have 525 on the left side of my equal sign, and on the right side, when I multiply 1/3 times 25 times 18, that is going to give me 150, and then h. I'm bringing down that h. Now, once again, I have a coefficient of 150 and a variable right next to it. And if I have to get that variable by itself, I am going to divide by 150 on both sides. So that gives me that h is equal to 3.5 feet. Okay, no cubic feet. I don't have that exponent because we are not dealing with volume. We are dealing with just height. Okay. All right, and once again, if you feel like you need to review the rectangular pyramid once more, go ahead and go back now. If you feel comfortable enough where you don't need to review that, go ahead and flip to triangular pyramids. Okay, and that's the last pyramid we are going to learn today. So with a triangular pyramid, we've learned a square. We've learned the rectangle is going to be our base, and now we have the word triangular, which means that we are going to have a triangle for my base. Okay, I'm still going to have the height, which is that line straight down in the middle, and then the sides that connect. Okay, now what a triangular pyramid is, it's a solid figure whose base is a triangle. Okay, and the sides are triangular faces. That meet, once again, at the apex, which is the top. Okay, now this one we cannot compare to a rectangle and a triangle because this one does have different characteristics. Okay, so you want to make sure you are looking to see that, hey, instead of my base having 4 vertices, I'm now going to have only 3. Okay, now that's not all of the vertices I have, but we want to make sure that I only have 3 sides instead of those 4 sides that I usually have for my base. Okay, now moving to my camera really quick. Here is my triangular pyramid. As you can see, different sides. I only have 3 different sides. Okay. And I want to make sure I'm counting the number of faces. Now remember, the faces are going to be our flat surfaces of my 3-dimensional shape. So this is a flat surface here. That's 1. I have 2 on the side. If I move my camera around, I have 3 over here. Okay, and then my final one, which is at the bottom, is 4. Okay, I don't have one on the complete other side because remember, this is a triangle, so I don't have those 4 triangle faces at the top. So the number of faces that I have, once again, I have 1, 2 on the side, 3 on the other side, and then 4 at the bottom. Okay, so the number of faces I have are 4. Okay, now this is represented by a triangle or triangular base, sorry, not face, and then 3 triangular faces on the side. Okay, now let's go ahead and take a look at the edges and the vertices. Remember that edges are going to be where 2 faces connect, which are these lines. So if I look, I have 1 line, I have 2, and then I have 3 right here, and the other side is flat, so there's not really another one. So I have 3 at the top, and if I look at the bottom, I have, 1, 2, and 3. Okay, so in total, I have a total of 6 edges, and if I'm looking at the number of vertices, I'm looking at the points. I have 1 at the apex right here, which is 1. Then on the sides at the bottom, I have 2. I have 3 right here, and then my final one in the back, which is 4. Okay, so it's the pointy parts. That's what I have. So I have 6 edges and 4 vertices. Okay, now if you give me a chance to build my triangular pyramid so I can show you the types of slices I'm going to have. So give me 1 second. I'm going to try my best to make this super fast. Okay, moving on to my camera. Okay, when I have my triangular pyramid, tried my best. Okay, when I do a horizontal cut, meaning straight through the middle, I'm going to ask myself, what type of shape do I have in the inside? And if you look in the inside, it's going to give you a triangle, okay? And the same thing goes if I make a vertical cut, okay, straight down the middle, what type of shape am I going to get then? Which I also end up with some type of triangle, okay? Now, obviously, it would be 10 times better if I actually had one that I can split, but that is the best I can do. So for a horizontal slice, you're going to have a triangle, and a vertical slice, you're going to have a triangle as well. Okay. Now with our net, remember that is a 2-dimensional instead of a 3-dimensional, so it is going to be laying flat on the table. Okay, and I'm going to show you that representation really quick. So I have my net right here. I have that 3-dimensional shape as a triangular pyramid. And if I were to cut along the edges, as I start separating them, this is the type of shape or net it makes when I flatten this 3-dimensional shape. So going back to my notes, I'm going to have one triangle, and then I'm going to have 3 triangles off of the sides. Oops, I did not want to grow. Okay. My drawing is a little rough, don't judge. Okay, now one thing to keep in mind with our triangles is we have a base and we also have a height. So let me change that. We have a height of the triangle, okay? Now you are going to have 2 H's. You're going to have one lowercase and you're going to have one uppercase. The lowercase is going to be the height of the triangle, and then the uppercase H is going to be the height of the pyramid, okay? So that'll make sense in a little bit. Now, the uppercase H cannot be seen because, once again, the height of a pyramid cannot be seen on a net. Okay. All right, moving on to volume. So the volume formula for this, once again, we have our basic formula, which is 1/3 times base times height. Okay, but then going a little bit more into detail, if I'm looking for the base, the area of the base of the triangle that we have at the bottom of our pyramid, in order for me to find the base of that triangle, it's 1/2 times base times height, and then the rest of the height of the pyramid, okay? So this one's a little bit longer. That's okay. The only thing I have to remember is that this uppercase B right here is represented by 1/2 times the base of the triangle at the base times the height of the triangle at the base, okay? So looking at example A, okay, first thing I'm going to do is I'm just going to write down my formula, which is 1/3 times 1/2 times base times height times the height of my pyramid, okay? So looking at my pyramid right here, if you kind of pay attention, some of them are going to have a right angle right there, and that's going to represent my base and the height. It's almost like if we were looking at a right, which this is a right triangle. Remember, with Pythagorean theorem, we knew that that L shape or wherever that right angle is going to be our legs, which is the base and the height of my triangle. Okay, so that's what we're actually going to plug in into the lowercase b and h. So I'm going to bring down 1/3, 1/2 as well. And then to plug in for the base, we have 15.1 times that 11.3. And then the height of our pyramid is 18. So we're going to plug that in into the uppercase H. Notice how we did not use that 18.9 because it's pointing at the hypotenuse of that base. So technically, we are not really looking at that, okay? Now, I have to go ahead and simplify. What I would recommend is separating them. So I would draw my line right here. Multiply your fractions first and multiply your numbers, like your whole numbers or natural numbers first, and then start simplifying with those fractions, okay? So when I multiply my fractions first, I get 1/6. And when I multiply 15.1 times 11.3 times 18, that is going to give me 3,071.34. Okay, now my last step is going to either multiply by 1/6 or I have to divide by 6 to that 3,071.34. Okay, when I multiply 1/6 to 3,071.34, my final answer is going to be 511.89 cubic centimeters. Okay. And doing the same thing over here, we want to make sure that we keep in mind that we have a 10.4 here, and that is telling me that that's the height of the triangular base that we have at the bottom, okay? So yes, we have 12 and 12, but one of them is going to represent the hypotenuse. So we only need one of the 12s, which is this one right here. So I have 1/3, or V is equal to 1/3 times 1/2 times lowercase b and h, which are the base and the height of the base, and times the uppercase h, which is the height of the pyramid. Now bringing down my fractions, I have 1/3 and 1/2. And to substitute, once again, it tells me that the base of this triangle base is going to be 12. And the height of the triangular base is 10.4. And the height of my whole entire pyramid, which is right here, is just 8. Okay. Now, to start simplifying, once again, I would do the same exact thing, draw a line to separate my fractions and my whole numbers. I have 1/3 times 1/2, which is going to give me that 1/6. And then I'm going to multiply 12 times 10.4 times 8, which is going to equal 998.4. Okay. And for my last step, I'm just either going to multiply by that 1/6 or divide 998.4 divided by 6, which is equal to 166.4. Okay, that's not my final answer though, because I still need a label. So my final answer is 166.4 cubic meters. Awesome. And moving on to our application story problem. So I have C, a triangular pyramid has a volume of 840 cubic inches. The triangular base has a base length of 20 inches and a height of 21 inches. Find the height of the pyramid, write the formula, show the substitution, and work. Remember to correctly label your answer. Okay? So, once again, they actually give us the volume. Therefore, we're not solving for V, we're plugging in something in for V. What we're really finding here is the height. So, once again, we're not plugging in anything for H, we are solving for H. So, I'm going to write down my equation, which is 1/3 times that 1/2 times the base times the height of the pyramid. Okay, so we're finding the height of the pyramid, so we are not going to plug anything into our uppercase H. Okay, so next step is substitution. I have 1/3 times that 1/2. Our base of the triangular base is 20 inches, and the height of the triangular base is 21. And I'm going to go ahead and put my H. Okay, now to simplify, you can do the same thing that we did previously, which is just separating our fractions to our whole numbers. So I'm going to have 1/6 times 420 times H. Okay, and then one thing I did forget was our volume, so you want to make sure you're plugging in your volume for V. Okay. And then I'm going to keep simplifying the right side of my equal sign because that left side of the equal sign is just 840. So there's nothing for me to simplify. So 1/6 times 420 is going to equal, and I'm going to finish my work over here, is going to equal 70h. And that 840 is just going to be brought down again. And my last step to get h by itself, remember there's no addition or subtraction, so you should not be adding or subtracting that 70 over. I'm actually going to divide 70 on both sides, which means the height of my pyramid is just 12 inches. Not 12 inches cubic, or not 12 cubic inches, just 12 inches because we're not dealing with volume. The volume was already given to us. All right, and the very last one, it says a triangular base of a pyramid has a height of 5 feet and the base of 13 feet. The height of the pyramid is 11 feet. Find the volume, write the formula, and show substitution. Okay, so writing my equation once more, I have V is equal to 1/3 times 1/2 of the base of the triangular base times the height of the triangular base times the height of the pyramid. Okay, bringing down my fractions, I'm going to substitute the lowercase b with 13. Okay, then the height, which is 5 of that triangular base, and then the uppercase h is going to be represented by 11 because it says the height of the pyramid is 11 feet. Okay, now all I have to do is go ahead and finish simplifying. You can draw that line to separate your fractions and whole numbers. So I have 1/3 times 1/2 is going to give me that 1/6. And 13 times 5 times 11 gives me 715. Okay. When I multiply 1/6 times 715, my final answer is 119.17 cubic feet. All right. Okay, so once again, if you feel like you need to go through all of this again, make sure you are rewinding to kind of see the examples again. If you don't have any questions, go ahead and start on that assignment.